In this video, we're going to look at factoring by taking out a greatest common factor. So we're going to draw on some things we've talked about already, including coefficients, polynomials, making factor trees. Creating factor trees are something we're going to use quite a bit. And so we have some problems over here. But let's start by talking about what is factoring. So when we multiply two numbers together, let's say we're doing 2 times 5. Remember, parentheses like this mean we're multiplying. 2 times 5 gives us 10. So we started here, we wound up here, we multiplied. But what if we started with this and then we said, okay, what numbers can multiply to give us 10? Let's break that into 2 times 5. So if you start here and you're going to this, that's basically what we're doing when we're factoring, or that is what we're doing when we're factoring. We're saying we're trying to break something apart into two things that are being multiplied. So this is a very simple example, just taking a number and breaking it down into two factors. We're also going to be taking something and breaking it into two factors, but it's going to look much more complicated. Instead of starting with the number 10, take number 1 up here, for example. We're starting with an entire polynomial, in this case, a binomial. Remember, binomial meaning 2. So we're going to take this whole thing, this 12x plus 16, and we're going to break that apart into two things being multiplied. There are different methods you can factor by. So there are different methods you can use to break down into the things that you're multiplying. The one we're focusing on today is called GCF. We're taking out a GCF. We're taking out the greatest common factor, which is probably something you've heard before, greatest common factor. We won't go into the other things just yet, but know there are multiple ways to factor. So how are we going to turn this into two things being multiplied? So to start off with, we're just going to focus on the process, the actual steps you take. When we do this a couple times, you may start to piece together what's happening. But for now, let's just focus on the steps. Here are the steps. Let's rewrite this. First step, put a box around each of your numbers. Now we're going to do something we've already done, which is create factor tree for each of these numbers. So remember, 2 branches coming off each, and pick any number that multiplies to give you these. So for 12, you can pick 2 times 6 or 3 times 4. Remember that you don't want to pick 1 times itself, any other pair. Then we say, let's look at this 2 first. Can we break down 2 further? What can you multiply to get a 2? Well, just 1 times 2. So if we did this, we'd have 1 times 2. But then we have a 2 again. We don't want that. So when you can't break it down further, you circle it. Make sure to circle it. But 6, you can do 2 times 3, not just 1 times 6. 2, we just saw 2's can't break down. Same thing with 3. 3 would just be 1 times 3, but then you just have a 3 again. So that doesn't help us. That means we can't break it down, so we circle it. So what this has just told us is that 12 is the same thing as 2 times 2 times 3. That doesn't sound right to you, try it out. 2 times 2 is 4, times 3 is 12. So whenever you break this down, all the numbers you circle should multiply to give you the original number. So 16, same thing. We can do 2 and 8 or 4 times 4. 2 we know can't break down, but 8 can become 2 and 4. 2's can't break down. 4 can become what? 2 times 2. And we know 2's we always circle. So as you do this more, remember there are certain numbers you just know because it's going to be the same thing every time. Every time you see a 2, you're going to circle it because 2's can't break down. They're prime numbers. 3's can't break down. You always circle 3's, 5's, 7's, and so on. So what we just found out is that 16 is 2 times 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So we've just found different ways to write this. So that's our first main step. Second step. So let's maybe put step 1 here. Now step 2 is we're going to rewrite our original expression. So that 12x plus 16, we're going to rewrite it But instead of putting the original numbers, the 12 and the 16, we're going to use these new prime factors that we just found. So here's what we mean. Let's start with the 12x. We're going to rewrite 12x. Instead of 12, we're going to put 2 times 2 times 3. Make sure to use these dots for the multiplication instead of the x symbol, because we're going to have some variables, oftentimes x's, and we don't want to confuse those with the multiplication symbols or confuse the symbols with the x's. So we just rewrote the 12. The 12 became 2 times 2 times 3. Now remember, looking back up here, remember that when you have a coefficient, it means multiplication. So 12x really means 12 times x. So let's just add that on the end, our times x. So now we just rewrote our 12x as 2 times 2 times 3 times x. We haven't actually changed it because those are the same thing. We've just expanded it out. And again, as we do more of these, start to think about why we're doing each of these steps. But for now, just focus on the steps. Okay, so then just drop down the same sign. So we drop down our plus symbol. If it was a minus, we put minus. And then we're going to do the same thing with the 16. 16 we found out is 2 times 2 times 2 times 2. We don't have to put an x on the end this time because the 16 doesn't have any letter here, no variable. So now we've done the second step, which is we rewrote our original expression as sort of in expanded form. And we should even put, let's take this out real quick. We don't have too much going on. We should even probably put an equal sign in front because these are equal. We didn't change the values of anything. We just rewrote it. It's important that they're still equal because we need to keep it equal. So now from here, next step. And let's just, for the moment, we'll take out that equal sign so we have a little bit of space. Let's imagine this whole thing is in parentheses. You can add parentheses around anything and it doesn't change the value if you're putting them around the whole thing, the entire expression. So picture this whole thing in parentheses. And before we get there, actually, let's focus on each term. So we had the 12x here and we had the 16 here. What we want to do from here is we want to circle everything that they have in common. So remember, this is called factoring out a greatest common factor. We're looking at what the common factors are, what numbers are multiplying in both of these terms. Well, this one has a 2, this one has a 2, this one has another 2, this one has another 2. And that's it. That's all they have in common. This one has a 3 and an x. This one has 2 2s left over. They have nothing else in common, but they had 2 2s. So that means, what do they have in common? They have a 4. And think about it. Does 4 go into 12? Yeah, 4 times 3. Does 4 go into 16? Yeah, that's 4 times 4. So we just found out, this was our expanded way of finding out the biggest number that multiplies into both of these, because 2 times 2 is 4. So now we're going to do what we put these parentheses here for. If they both have that same number or the same common factors, we can take those out of each of them and put it in front of the parentheses. So here's what we mean. We're taking 2 2s out of each of them. So we're taking a 4 out of each of them. So moving on to step 3, we're going to put that 4 in front of the parentheses now. Next step, we look at whatever we didn't circle. So come back over here. We didn't circle the 3. We didn't circle the x. What is 3 times x? That'd be 3x. Now drop down your symbol. We had plus. If it was minus, you'd put minus. And then look at the other term. We didn't circle this 2 or the other 2. 2 times 2 is 4. So drop down the 4 here. So why were we able to take the 4 and put it on the outside? Because this one had a 4 and this had a 4. Why could we just take it and put it on the outside? Well, think about what we learned with the distributive property. When you have something on the outside of parentheses like this, what happens? It multiplies to everything on the inside. So if you were to multiply this back together, you do the 4 times the 3, the 4 times the 4, and it goes back into both of them. That's why we can take it and put it out front. But we don't want to multiply these back together. Why not? Because we'd wind up back where we started. Remember, with factoring, we're trying to pull the thing apart. If you wanted to undo that, you would just multiply them back together. So we can multiply to check our work. Let's try it. 4 times 3x is 12x. 4 times 4 is 12. There was the plus sign in the middle. 12x plus, oh, sorry, 4 times 4 is 16. Oh, there. 12x plus 16. So then you would see this is what we started with. So we know we wound up with an equivalent expression, which is important. So in any case, that's just checking. You don't need to do that. We have our answer here. We did the correct steps. And so this is our answer. Notice that we started with, and let's make some room. We started with 12x plus 16, and we wound up with 4 times 3x plus 4. Just like earlier with our example, we took a 10 and we broke that into 2 times 5. Same thing happened here. If we want to make them look more similar, you can just put this 4 in parentheses. You have two things being multiplied. You have two things being multiplied. 10 is equal to 2 times 5. 12x plus 16 is equal to 4 times 3x plus 4. And again, if it's not all clicking yet, don't worry. We'll go through some examples. For now, again, focus just on the steps. We had 3 steps we did. Let's move on to number 2. Five y minus 10. So same thing, and we'll go through this one a little bit more briefly. Box around the 2 numbers. There could be more than 2 numbers, but for now, we're just going to focus on ones that have only 2 numbers. Factor tree for each of these. 15 would be 3 times 5. Neither of those can break down, so circle them. 10 would be 2 times 5. Neither of those break down either, so circle them. So step 1, make your factor trees. Step 2, we're going to rewrite our original expression using these prime factors. So instead of the 15y, we're going to rewrite it as 3 times 5, and then we'll just put that as times y. You don't really need to put that times there, but or that multiplication symbol, it just kind of makes it a little bit more consistent, I think. So now drop down the sign, and what sign are we going to drop down? This time it's minus. Last time we had plus, this time we have minus. So it's just whatever sign is there. And then 10 we're going to rewrite as 2 times 5. So that's step 2. And now kind of part of this step, or you can think of it as separate, we're going to circle what they have in common. So we have 2 terms. Remember, a term is something separated or multiple things separated by addition or subtraction. So what are we going to circle here? What do you think? Well, they both have a 5. Do they have anything else we can circle? No, not this time. They only have one thing in common. So we imagine this whole expression being in parentheses, and then we're going to pull that 5 out front. Now, careful, a common mistake would be to multiply this. Say, okay, 5 times 5 is 25, so we're going to put a 25 in front. That's not true. You're taking a 5 out of each of them. You would only multiply it if you were taking 2 5s out of each of them. Then it would become a 25. But don't let me confuse you with that side note. So they both have a 5. Now let's move on to step 3. They both have a 5, so we put the 5 in front and then our parentheses. And then what are we left with? Well, we come back to our terms. What did we not circle over here? Well, we didn't circle this 3 or this y. Everything's being multiplied, so just multiply them. 3 times y is 3y. Drop down the sign, which is minus. And then what did we not circle over here? We didn't circle the 2. And there's our answer. We have 2 things being multiplied, the 5 times this whole thing. And again, if you want to, you can put this in parentheses. They don't need to be there, but you can. So there's our answer. Again, you can double check by remultiplying them back together. So distributing 5 times 3y would be 15y. 5 times negative 2 would be negative 10. 15y minus 10 is what we started with, so that looks good. when you're checking like that, you want to make sure it equals the original expression. If it doesn't, you either multiplied wrong or one of your steps, you might have made a mistake. So go back and revisit if you get a different thing when you're checking, different expression. Okay, next one, 6x plus 8. So I encourage you to pause the video and try this one out. See if you can do this one. So box around the 6, box around the 8. Factor trees, 6 would be 2 times 3. 8 would be 2 times 4. That's step 1. We did our factor trees. Step 2 is rewrite it. So 6x, we're going to write as 2 times 3 times x. And then 8, we're going to write as 2 times 2 times 2. We drop down our plus sign in between. Again, it's just whatever sign is in your original expression. Now we're going to think about both of our terms and circle whatever they have in common. What do they have in common on this one? Looks like just a 2. And again, think about it. What's the biggest number that can go into 6, that can multiply into 6 and multiply into 8? It's 2. 2 times 3 is 6. 2 times 4 is 8. We're just doing an expanded version. Again, I think we said this. We're doing an expanded version that helps you figure that out step by step. So they both have a 2. Again, think of the whole thing being in parentheses. We can now take the common factor and put it on the outside. And 2 is now on the outside. Look at what we didn't circle. We didn't circle the 3 and the x. 3 times x is 3x. Drop down the plus. We didn't circle either of the 2's. 2 times 2 is 4. So there's our answer. So before we move on to the last one, let's make one thing clear. So going back to number 1. So we talked about, we just kind of mentioned where that term common factor comes from. We're looking for the factor that they both have in common. But what do we mean by greatest common factor? So if we go back to this one, when we had it expanded out, we had 2 times 2 times 3 times x plus 2 times 2 times 2 times 2. That's what we had when we expanded it out. We circled one number. We said they both have a 2. So 2 is a common factor between 12 and 16. But like the title implies, we're looking for the greatest common factor. So while 2 can go into 12 and 16, 2 times 6 is 12, 2 times 8 is 16. We want to know the biggest number that can go into both of them. That's why we have to keep looking. Oh, they have another 2. So yes, 2 can go into 12. Whoops. 2 can go into 12 and 2 can go into 16. But if we notice there are 2 2's, that makes 4. Because actually 4 is the biggest number that can go into 12. 4 is the biggest number that can go into 16. So that's where the name greatest common factor comes from. We want to know the biggest number, not just any number, because sometimes there's more than one that can go into both. We want the biggest one. So that's just a little side note. Let's move on. Last one, number 4, we're actually going to change a little bit. Let's make it 8x minus 9. The reason we're changing it is because it's going to show us a little bit of a twist, something that can happen sometimes. So let's take this 18x minus 9, and let's do the same thing. 18 can become, and see while we're doing it, if you can think of what the problem that's going to come up is, and maybe how to address it. So 18, 2 times 9, or 3 times 6. 9 would become 3 times 3. That's step 1. Now we rewrite it. 2 times 3 times 3 times x minus 3 times 3. Now we look at our terms and circle what they have in common. So what are we going to circle? We're going to circle a 3 and another 3. Okay. Again, think about what the problem is going to be here. Now we take out those common factors. We can put them on the outside. So we're taking 2 3's out of each of them. That means we're taking 3 times 3, which is 9 now. So on the outside, we're going to have a 9. And then what are we left with? Well, this one we didn't circle the 2 or the x. What's 2 times x? 2x. Drop down the sign, that's minus. And then here's the problem. We took out both these 3's. So what do we put there? We don't leave it blank. We need to put something there. What are we going to put there? Well, maybe we're not sure. Maybe we think 0 might work because there's nothing left, but let's see what it is. So remember we said we could check our answer by multiplying the terms back together. So you would do 9 times 2x, which would give us 18x. That's good. But then we need to do 9 times something, and that gives us 9. So that's gonna tell us what number we have to put there. What number would we have to put? If we want to do, we said 9 times 2x is 18x. That's good. And then 9 times something is going to give us 9. What goes there? It's going to be a 1. So it turns out that's how it works. If there's nothing left, we circled everything. We took everything out of this term. If there's nothing left, you put a 1. That's just always what you're going to do. When you take away everything, when there's nothing there and you're talking about like addition or subtraction, that's when you have a 0. But here we're focusing on multiplication. When you take away everything in multiplication, it's technically a 1 that's left over. So this would be our answer for number 4.